Okay, so moving on to question A2 now. This question, it tells you exactly where alpha and beta lies in. And in this case, alpha is lying in the second quadrant and beta is lying in the third quadrant. I would say that this question is pretty straightforward in a sense. It tells you exactly where these two angles lie in. Sometimes the question may not tell you which quadrants our angles lie in. You are supposed to infer on your own based on some of the values given. I'm sure along the practice, along the way, you come across such kind of questions before. Not to worry, I believe it should also be in your practice worksheet. But nonetheless, let us have a look at part 2 now, okay, where you're supposed to find out what sine 2 alpha is. But before that, I would say it is a good idea for us to draw this up first for alpha, and it's lying in the second quadrant. So this is how alpha is. And it says cosine alpha is negative 4 over 5. That means to say this is a 4. But because this here is negative 4, and my hypotenuse should be a 5. So what does that leave our height to be? Okay, if you take this as a typical right angle triangle, okay, by Pythagoras theorem, 5 square minus 4 square is equals to 3. Okay, in fact, this working here, I would say it's redundant. You don't have to show this, but I'm just showing you guys for the benefit of some of you who might be confused as to how I got 3 for the height of the triangle here. So in any case, from here, we would have known that sine alpha is actually 3 over 5. And tangent alpha, okay, is opposite over adjacent is negative 3 over 4. Okay, so back to the question. It is asking for sine 2 alpha. So what happens is this, if you can recall your double angle formula, sine 2 alpha is 2 sine alpha cosine alpha. And from here, I already have all the different values because cosine alpha is given to us as negative 4 over 5. I shall just substitute all my values in. Okay, so eventually you should have negative 6 times 4 is 24 over 25. So this is your answer for part 2. Okay, so in the case of beta, given the relevant information that sine beta is negative 5 over 13. Okay, so this is what I've drawn and what I've come up with. All right, now this over here is basically the so-called the magnitude lah, the length of the triangle. But not to forget, this is actually on the axis, which explains why it's negative 5 and negative 12. Hence also explains why your sine beta is negative because it's rightfully negative 5 over 13. And also your cosine beta is rightfully negative 12 because it's behind this axis over here. It's a negative value, negative 12 over 13. And also your tangent beta in this case is opposite over adjacent, which should be negative 5 over negative 12, and therefore it's 5 over 12. Okay, of course, you can give me this right at the start. Yeah, it's perfectly fine. So question now wants to have cosine 2 beta. There's a few ways to go about getting this. One of it, cosine 2 beta, has quite a number of different trigo identities. One of it is 2 cosine square beta minus 1. And you should get 2 times negative 12 over 13 square minus 1. Okay, key this into your calculator. You should get 119 over 169. All right, or some of you, okay, you may not want to use this trigo identity. You may want to make use of 1 minus 2 sine square beta. Okay, this is another trigo identity for cosine 2 beta. It should lead you to the same answer as well. Yep, 119 over 169. Okay, or another trigo identity you can use for cosine 2 beta is cosine square beta minus sine square beta. Either one of these three are acceptable, yeah? So they should be negative 12 over 13 square minus negative 5 over 13 square. And this should lead you to 119 over 169 as well. Okay, you just have to show me either one of this set of working. Okay, it's all acceptable. Okay, now moving on to part 4, where you are asked to find the value of cosine half beta. Okay, so all of a sudden this is a little bit more tricky over here. Okay, why do I say that this is tricky is because we are only given cosine beta to work with. All of a sudden, I'm given half beta. Now, what I can do is this. Okay, I can consider cosine beta. I treat cosine beta as a double angle. And how do I do that? It is simply just 2 times half beta, isn't it? This is just cosine 2 times half beta. So right now I'm seeing this as my single angle with 2 times this becomes a double angle now. And if I do apply my double angle formula, okay, this will be 2 cosine square beta over 2 minus 1. Isn't it? Because if you can recall, cosine 2 alpha is equals to 2 cosine square alpha minus 1. Okay, I'm simply just applying it over here. Alright, so from here, I can move things around. Okay, I can move 1 over, so this is 1 plus cosine, this is actually just cosine beta, equals to 2 cosine square beta over 2. So to find cosine square beta over 2, it is half times 1 plus cosine beta. Okay, so this is something that we should bear in mind over here. So now let's go set off to find what is cosine square beta over 2. Cosine square beta over 2, cosine square beta over 2 is simply just half times 1 plus cosine beta, as according to the question is negative 12 over 13. And this should lead us to 1 over 13, which is 1 over 26. Now, when I want to find cosine beta over 2, this should give me plus minus square root of 1 over 26. And I should get 1 over square root 26 or negative 1 over square root 26. Okay, so now I have two answers. Do I accept both answers? Okay, before we blatantly say yes or blatantly say no, it is good for us to actually consider the range of beta values over here first, because our dear beta is between 180 to 270. So if I'm talking about beta over 2, I am talking about beta over 2 being between 90 to 135. So if I have cosine of an angle that is lying in the second quadrant, okay, cosine of an angle that's lying in the second quadrant, what do we know? Okay, so in this case, cosine beta over 2, which lies in the second quadrant, should be less than 0. And therefore, we should reject our positive answer. Okay, so therefore cosine beta over 2 is equals to negative 1 over square root 26. Okay, yeah, so that's it for this question. Thank you.